create this universal coupling by using bottom-up approach. So in bottom-up approach, first we need to create here single individual parts, and we will save these parts in one separate folder. Later we will enter into assembly design. From there we will call single individual parts and we will make it this assembly design. So now let's start with parts. Now let's create this fork now. So for that, just I'll enter into here part design. Now while entering into part, we need to specify here part name. I'll give here fork. Let's say okay. Now to create this fork, first I am going to start with this circle with a diameter of 54. It should make pad of 33. Now I am going to create one sketch on right plane. Just I'll make it here proper orientation. We need one circle here with diameter of 54. Then it should be make pad of 33. So let's make this pad of length 33. Then next to that we are having here one rectangle. So just I'll create this rectangle. I am going to use on front plane. One rectangle I will draw here by using center point rectangle like this. Then by using constraint relation between this line to this line, we need here coincidence. Then dimension from this origin point to this line we are having here horizontally 51. From this to this we are having here horizontally 51. Then as you can see here, this total height we are having here 96. So just I'll give this height 96. Exit workbench. Then make pad by using mirror extend. This width we are having here 54. So whenever we are going to use this mirror extend, we need to provide here only half dimension 54 by 2. Then next to that we are having this shape. So we are having one inclined and curve profile on this top view. So whenever we are having any inclined or curve profiles, on which view we are able to see that profiles, on the same view we need to draw. It means this inclined and curve profile we are able to see from top view. We need to create this shape on top plane only. Why? Because this inclined and curve shape you are not able to get from front plane. Now let me go for sketch on this top face. Just I'll make it here proper orientation. So to make this as a closed profile to make pad, here one line also we needed. So instead of creating one line and making constraints, directly we can use here project 3D elements and we can convert that into normal sketch. Then just I will go for profile. From this endpoint we are having one inclined line. Along with that we need one tangent arc like this. Then this line should join exactly here. Just I'll go for constraint relation between these two. We need here tangency between curve to line like this. Then radius for this they have given 24, dimension from origin to center point 70. So this radius we need here 24. Then this point should be exactly on this horizontal axis. Let's make it coincidence. Then this point to origin point we are having here 70. So just I'll provide the dimensions. Now as you can see here, profile is iso constraint, and if I check here, it is a closed geometry. Then exit workbench, make this pad in reverse direction with width of 15. So just I'll give here width of 15. Now same with this shape with width of 15, we need here also directly we can go here with mirror. Let's say yes, with reference to this top plane, say okay, like this. Now addition of material done. Then we'll go here with this removal of material with this shape. So here we are having one slot. Like while making assembly design, we need to insert here one taper pin. So for that, just I'll go for creating sketch on this face. We are having one circle here. Then one slot profile like this, one vertical line, one horizontal line, then one vertical line. Now let's go for trim and trim these unwanted elements. Dimension for this circle we are having diameter of 30. So just I will provide here diameter of 30. Then relation between line to line, we need here symmetric relation with reference to this. It means whatever the dimension we are having from this center line to this one, same it will be distributed here if we apply symmetric relation. Then this length we need here 9 mm. This height we need here 5 mm. As you can see here, this height we need 5. Now exit workbench. So with this shape we need to remove material. Directly we can go here with pocket, and this pocket depth we need up to next. Let's say okay. Again next to that we are having here dress up features. It's nothing but fillets, any chamfers. Now as you can see here, radius of 3 we are having for this curve part. So let's go for fillet. So we need fillet exactly here and here with radius of 3 mm. Then next to that we are having here radius of 9 for this edge. So radius of 9 for this edge and this edge. Then radius we are having here 9. Let's say okay. Then later to that, at last we will go for creation of these holes. One hole we are having with a diameter of 18, exactly center point of this radius 24 curve. So whenever we want to create exactly center point of that already existing circles, instead of selecting this face, first we will select this curve, later we will select this surface. Properly hole will be created at exactly at center point. Diameter we need 18, depth up to last. Let's say okay. Now let me apply some color for this by using properties. So I'll apply some color to this. I'll save this file in a separate folder as we are going here with bottom up approach. So I will enter into here assembly design. Already I have created one folder universal coupling. So just give part name fork 1. Let's save this part. Just close it.